Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 15 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2560, House Robber 4. Okay, so let's read the problem statement first. There are several consecutive houses along a street. Okay, each of which has some money inside. Okay, there is also a robber who wants to steal money from the homes, but he refuses to steal from adjacent homes. Okay, so let's say there are five homes: A, B, C, D, and E. Okay, so if robber is stealing from house A, then after that he is not going to steal from house B, because this house B is adjacent to house A. Okay, so next time he is going to steal from house C. Okay, and then same way, if he steals from C, then next time he is not going to steal from D, but he is going to steal from E. Okay, for the next time. So he is not going to steal from the adjacent houses. Okay, done. All right. Now the next point. The capability of the robber is the maximum amount of money he steals from one house of all the houses. From one house of all the houses he robbed. Okay. So what is the capability of the robber? So let's say robber steals money from house A, then robber steals money from house C, then robber steals money from house E. Okay. Then the capability of the robber is the maximum amount of money, okay, max amount of money that he steals from one house of all the houses he robbed. That simply means A, C, or and E. Okay, so from all these houses, what is the max amount? Okay, let's suppose from A he steal $2, from house C he steals $3, and from house E he steals $4. Okay, so max among them is 4. Okay, so 4 is nothing but it is the capability of the robber. So capability of the robber is the max amount of money he steals from one house of all the houses he robbed. Okay, so here this is important word. Okay, max. Capability of the robber is the max. Okay, so just remember this keyword, max. All right, now you are given an integer array nums representing how much money is stashed in each house. More formally, the ith house from the left has nums of I dollars. Okay, you are also given an integer k representing the minimum number of houses the robber will steal from. Okay, it is always possible to steal at least k houses. Okay, this is very important line. Okay, mark this line. It is always possible. Okay, it is always possible to steal at least k homes. Okay, this is given in the problem statement, that whatever the value is given to us, so it is going to be always possible to steal at least k houses. Okay, and here before this line, see this line, you are also given an integer k. Okay, so this integer k is given to us, which is representing the minimum number of houses the robber will steal from. Okay, so k is equal to 2, so robber should steal from at least 2 homes. Okay, at least 2 homes. We have to return the minimum capability of the robber out of all the possible ways to steal at least k houses. Okay, so 2 is the minimum. Okay, he can steal from 3 homes, he can steal from 4 homes, he can steal from 5 homes. Okay, right, but at least k should be there. Okay, so here first of all let's see this example. Okay, so we have nums like 2, 3, 5, and 9, and k is equal to 2. Okay, so let's say first robber steals money from this house. Okay, 2, then next time he can't steal money from this house, he can steal money from this house, or he can steal money from this house. Okay, so if robber steals money from first this house, okay, that is 2, and then next time he steals money from this house, that is 5. Okay, then after that he can't steal from this 9 from this house, right? So here let's give na A, B, C, D. Okay, so if he steals money from house A, the next time he can steal money from house C or D. Okay, he can't steal from B. Okay, so if he steals money from house C, then 5 I'm writing, then next time he can't steal money from any other house. So here what is the max that we are getting? 5. Okay, now if robber steals money from house A, then after that instead of B, okay, B is not possible because it is adjacent to house A, right? And C is possible, but instead of C he steals money from house D. So 2 and 9, so among 2 and 9, which is max? So 9 is max. Okay, so here I'm writing, but I'm writing capability. Okay, capability. Okay, you understood this definition, right? Here the definition, the capability of the robber. Okay, so this is what I'm writing. Then okay, this is done. All right, there is no other way. Okay, so now let's start. Let's say the robber is going to steal money from this house B first. Okay, so if he steal money from house this B, then only option is to steal money from D, from house D. Okay, so here 3 and 9, but is the capability 9. Okay, done. So now here we have values 5, 9, and 9. Okay, so among them also from them we have to return the minimum capability. Okay, and capability is nothing but max. Okay, so here among them what is minimum? Minimum is 5, so we are returning 5. Okay, so there are 3 ways to rob at least 2 houses. Okay, so here 5 9 we are getting 9 we are getting. Okay, just read all this statement, then we have to return. Okay, so here what we are doing, we are finding here minimum capability, and capability is nothing but the maximum amount of money. Okay, so whenever our problem statement says minimize the maximum, okay, minimize the maximum, or it says maximize the minimum. Okay, so then think about binary search. Okay, whenever your problem says something like this, then always think about binary search first. Okay, binary search. Okay, so in the past also we have solved many problems like this. Okay, where in the problem statement it was mentioned like minimize the maximum or maximize the minimum. Okay, so just search, just think about this binary search first. Okay, so here there is one more thing that comes to my mind first initially, that we can apply recursion here as well, right? So it is like this now, 2 3 5 9. Okay, we have houses like 2 3 5 and 9. So here k value is 2, right? K value is equal to 2. So here what I was thinking, so if the robber steals money from this house, so let's say he steals money from this house too, so next time, this is my array, right? 2 3 5 9 9. Okay, so next time my eye is going to point to this, right? Initially my eye is here. Okay, so if he steals money from this, then 3 is not there in our option, right? Okay, so if he doesn't steals money from this house, okay, so here take, okay, take, and here skip. Okay, so if he doesn't rob the money from this house, then next time my eye is going to be at this index. Okay, here. All right, so here also you have again two options. So here if he steals money from this house, so one house is done. Okay, for a thief one house is done. Okay, so he should rob at least two houses. Okay, now next time again he has two options, whether he want to steal money from 5 or skip it. Okay, so let's suppose he take, okay, here take money 5. Okay, he's robbed this house as well. So next time my eye is going to point out of bound, right? Here eye is going to be at this position only. So here he robbed the second house as well. Okay, so at least two houses are done, right? At least two houses are done. Okay, so among these houses you have to consider the max. Okay, 2 and 5, what is max? So 5 is the max. All right, done. So here this house and then this. Okay, then here if he doesn't rob this 5, then 2 3 5 and 9, then my eye will go here, and still only one house is robbed right now. Okay, he doesn't rob this house. Okay, then again here he has two options, whether he wants to rob this house 9 or not. So 2 3 5 9, so let's say he robbed it, then my eye is going to go out of bound. So here he robbed this, so here 9. Okay, so here all the houses are robbed. Okay, two houses are robbed, right? At least two, so greater than two. Okay, okay, so we are done now. At least two is at least two should be there. But here if he doesn't rob, so here 2 3 5 9, and my eye goes out of bound. Okay, and then you, okay, so we have to stop, but only one house is robbed now. So this is not the best case. Okay, this is not the best case. So here there are two paths in this way. Okay, so 2 and then 5, or this 2 and then we skip this and this 9. Okay, so 2 and 5 max is 5, 2 and 9 max is 9. Okay, so from here 9, so this is 9 and this 5 is nothing but the capability of the robber, right? So using a recursion I'm doing right this. So same way you have to draw the tree diagram for this. Okay, here's in the skip part. Okay, so if okay, tree diagram will be very big. Okay, if you take this 3 or skip it, then next time if you take 5 directly or skip, okay, so tree diagram is going to be big. Okay, so you can draw this tree diagram. Okay, so using this you may be able to pass a few test cases. Okay, but C size is very large. Okay, and k value is also going to be very large, right? So definitely using memoization also I don't think that all the test cases will be passed. Okay, using this recursion or and memoization. Okay, so I don't think there is any possibility, right? So right, so instead of this directory, just first find out this keyword. Okay, if it is there, then try solving this. Okay, and you can actually do the practice, okay, using recursion also. So you can write the code and see how many test cases you are getting passed. Okay, and then just paste the solution in the comment section. Okay, I will just review it. Okay, so let's see how many test cases you are able to pass using recursion and memoization. Okay, so this is your homework. All right, okay, and here just one more hint, you can actually stop after robbing just two houses. in the problem statement it is saying that you have to rob at least two, right? So two houses or three or four or five. Okay, so instead of this you can stop your recursion tree with just stealing from just two houses. Okay, exactly two houses. You don't need to check three, four or five. Why? Okay, let's see. So here, let's say this is one pattern, this is one pattern, okay, of houses robbed, and this is one pattern, okay, of houses robbed. All right, so here you are calculating the capability, right? Here you are writing the capability. Okay, so let's say here you are robbing house, first $2 and then $5, okay, and then there will be some amount, okay, and from here you are stealing 1 and 3 only in this, okay, and here just until here only, okay, and here in this house you are stealing 2, 6, and there are so many values here also, okay. So from here you are picking up the maximum amount, okay, maximum. All right, so here from this house, let's say maximum is somewhere here 100, okay, 100. All right, and here your maximum is just 3, okay, and here your maximum is just from here your maximum is just let's say here say somewhere 200, okay. So out of these three, what is minimum? Minimum is nothing but 3, so 3 is your answer, okay, 3 is your answer, right? So now here in the problem statement it is not necessary now. Okay, so here see, you are also given an integer k representing the minimum number of houses the robber will steal from. Okay, it is always possible to steal at least k houses. Okay, so here there is no requirement actually for thief. Okay, so if a thief is happy to steal just these two houses, then he is happy now, because we just need the minimum. Okay, so we need the minimum, so it's not like in our mind, okay, thief needs more money. Okay, we are good. If thief needs more money, then thief is happy, but we want the minimum. Okay, so we want the thief to steal the least houses, okay, the houses with the least value. Okay, we are happy, right? We are happy with the thief stealing money from the houses having least value. Okay, having just value like 1 and 2, okay, if possible, that's it. Okay, it's not like we want so many houses to be robbed. Okay, so we are good. Okay, so it's like this. Okay, so let's say you have values like 2, 4, 6, 8, 10, 12, okay, and then 14. Okay, so here you want the maximum among minimum. Okay, this is what you want. First you have to find the maximum capability, and out of that maximum capability you want to find the minimum. Okay, right? So here let's say you are following some pattern, like first you robbed this 10, 12 and 6. Okay, then you see that robber can also steal this, okay, 2 and 4. Okay, this is also one way now. Okay, at least let's suppose thief doesn't see this house, this house, this house, this house. Okay, he is only able to steal these two. Okay, so 2, 4. So from here we have satisfied the criteria that we have that the thief has stolen from at least two houses. Okay, by just stealing from 2 and 4. So from here we get the maximum capability 5. So we can just ensure that this is the minimum one also. Okay, right? Because here at least 2 now, so why we want thief to steal for money from all the other houses? Okay, because we in the end we need minimum only. Okay, so I want the minimum values here only. Okay, so that's why we can keep this into check. Okay, that only 2 houses are getting robbed, that's it. Okay, we can stop from there. Okay, then we will find other pattern, okay, with this. Okay, so that's the reason. Okay, thief is stealing at least 2 houses, right? Then after that you want to add more houses, then it will automatically increase the complexity. Okay, you are adding more test cases, okay, all that stuff. But he can stop here now, so adding all this will only increase the value. Okay, increase the value, but we want the minimum in the end. So if we take just this 4 out of this, then that is one pattern, value pattern. Okay, this is one capability. So in the next pattern, let's say thief steals money like 101 and 108. Then after that he may get 2, or he may get some bigger value. Okay, so instead of taking all this and this, just add 108 now. This is also one value now, because in the end what we need the minimum among all this. Okay, so I hope that now you are clear with this, right? So yeah, this little bit. Okay, we go into this recursion part. Okay, but let's not waste the time using this take and skip, okay, recursion memory approach. You guys do the homework on this. Okay, write the code and paste it in comment section. You will get time limit exceed error for sure. Okay, that's a guarantee. Okay, but still paste the code so that others can refer, okay, how you are writing the code. Okay, and I will also review. Right now let's solve this question using binary search. Okay, and you know why we are moving toward binary search? Because of this, minimize the maximum or maximize the minimum. Okay, due to this, right? So now see here, example number 1, we have a nums array like this 2, 3, 5, 9. Okay, so here uh, let's use this pen. 2, 3, 5 and 9, and my k value is 2. Okay, so at least 2. Okay, so now here let's give the indexing 0, 1, 2, 3. Okay, so now same binary search logic that we usually do, that is nothing but we have to take the 2 pointers, that is one is left. Okay, so here let's start. Let's take your left. Okay, so minimum is always going to be 2 now, right? Or instead of going iterating over all the elements, or we can also iterate, right? Because we need to find out max number of reward. Okay, so here what I'm saying, that it is always possible to steal at least 2 houses, right? So if the user steal, let's say, these 2 houses, then the max is always going to be some house value only, right? It may be 5. Okay, if user steal this house, then it may be 9. So always my max or upper value is always going to be the max value in my array, right? Because we can't steal more than that particular house value. Okay, our capability is nothing but the max of the houses which a thief has robbed. Okay, A, B, C, let's say these houses are robbed, so among them whatever the max is going to be the capability, right? So this is given in the problem statement. So let's say this is house A, this is house B, and this is house C, and this is house D. So among these houses, the D house has the maximum money, right? So this is going to be my upper limit. Okay, so here what you can do, here you can create one pointer, let's name it as R, or let's name it as max reward. Okay, max reward, it is nothing but my max reward. Okay, so upper limit or max reward you can say. So you have to iterate over your complete array and find out the maximum. So maximum is 9. Okay, same way you have to take L left or lower bound or lower reward, lower value, or you can say min reward. Okay, min reward. Okay, so here min reward is going to be 2, right? It is going to be 2. Or you can take, if you don't want to iterate over complete array, then you can take 1 as well. Okay, so we can say that at least 1 is going to be the min reward. Okay, so I don't think there is any house value whose value is going to be 0, right? See, no. Okay, so it is starting from 1 to 10 to 9. Okay, so we can take a min reward in the starting as 1. If you want, you can take 2 as well. Okay, then you have to just iterate over all the houses and you have to find out the minimum of them. Okay, so it's your choice. Okay, so I will take 1. Okay, if you want to take 2, that is also good, no issues. All right, so this is done. Now here how many total houses are there? So let's create one variable, total houses. Total houses, and total houses are 4, right? Done. Now we have to do the binary search. So binary search has simple logic now. While my min reward is less than max reward. Okay, so what we do, min reward is this, max reward is this. We are going to run one while loop, and inside this while loop we are just going to write while my min reward, okay, min reward is less than max reward. All right, so here inside this, what we are going to do in binary search, we are going to calculate the mid value. Okay, so I can say int mid reward. Okay, mid reward. Okay, and here in mid reward I'm going to write this min reward plus max reward, that is nothing but 1 plus 9 divided by 2, I will get 5. Okay, so now this mid reward value is 5, so I want such pairings in which I get the max capability as 5 only. Okay, so here this 5 is nothing but I want such type of pairs. Okay, I want to form such type of pairs where I will get the 5 as a max capability. Okay, so now just iterate over all these houses one by one. Okay, so here this value is less than 5, so yes, we can steal from this house. Okay, so we can take this in pair. Okay, then after that, okay, if we are stealing from this, okay, so if we are stealing this, then we have to skip this now. So now instead of checking this, next time I'm checking this, so I can take money from this house, right? So it is, this value is also less than equal to our mid reward value, right? So yes, so here, so yeah, from this house also. So if the thief steal from this or this, so definitely, so how many total thefts are, total thefts are 2. Okay, so I will check that this total thefts, okay, is greater than equal to k. Yes, okay, it is greater than equal to k. So with the 5 I'm getting the answer. Okay, with the 5, okay, with the 5 I'm getting the answer. Okay, because I can steal from this house. Okay, and I can steal from this house. Now I have to minimize the capability. Okay, first I have to find the capability. Okay, this 5 capability. Now I have to minimize this as well, right? So how we do that? So here we are iterating over complete array, and then we are calculating the number of possible thefts. Okay, possible thefts. Okay, so it is given in the problem statement, right? This line is important. That, okay, So this line is important. It is always possible to steal at least k houses. So that is why we are using greedy approach, and I am iterating over all the elements one by one, okay, and finding out how many houses a thief can steal the money, right? So that is done. Okay, now I want to see 5 with the 5 answer is possible, but I want to minimize it because in the end we have to minimize the maximum, right? So now what I have to do here, so if these possible thefts, okay, possible thefts is greater than equal to k, so right now it is true in this case, then I will just decrease the value of max reward. Okay, I will just operate the value of max reward as mid reward. Okay, so that simply means that my max reward is going to be 5. Okay, my max reward is going to be 5. Okay, so this value. So now min reward is still at 1. Okay, my max is at, I set it to mid reward here. Okay, and that simply means that it becomes 5. Now my new mid is going to be 1 plus 5 divided by 2. I will get nothing but 6 by 2. I will get 3. So now with 3 I will check. Okay, so with 3 is it able to we are able to steal the money from all the houses, from the at least k houses or not? So with the 3 I'm not able to steal the money from this house, right? No, I'm able to steal the money from this house. Why? See, capability is 3. Capability is 3. So I want the capability 3, okay, in this pair. Okay, so this 3 is nothing. Capability is nothing but max values among the pairs, whatever the pairs that I get inside this. Okay, whatever the values we get inside this. So we can place 2 here. 2 is minimum. Okay, we can place here. So if I'm using 2, I can't use this 3. I can use this 5. Tell me, I can use this 5? No, because if I use this 5, okay, if I use this 5, then the max will come out as 5. It will not come out as 3. Okay, so it is not possible. So I can't use this 5. Okay, then can I use 9? I can't use 9 as well. Okay, so if I use 9 here, then capability come out as 9. Okay, but I need 3 money. So with 3 answer is not possible. So if answer is not possible, so in the else part I can say, then in that case we have to update the min reward. Okay, so in that case we have to update the value of min reward as mid reward plus 1. Okay, mid reward value plus 1 from last case time. Okay, so now min is going to be mid reward. Okay, this 3 plus 1 plus 3 plus 1, so I will get 4. Max is 5. Okay, now again you have to calculate mid. So mid is nothing but min plus max, that is 9. 9 divided by 2, you are going to get 4. So now again see, again if you see this while loop, 4 is less than 5. Okay, so this is still valid. Okay, so again we have to calculate it, everything. We get 4. So with the 4, how many are possible? We need max capability as 4 here. So here if you see, we can steal money from here. Okay, we can keep it inside this. Then after 5 is the option. So if I place 5 here, then I will get minimum capability here 5. Okay, that is not best answer. Okay, so I can't place 9 here. So with 4 also answer is not possible. So if answer not possible, then I have to increment the value of min reward. Okay, so now I'm going to increment the min reward as mid reward plus 1. Okay, so again here min reward as min reward. Okay, so here let me use this pen. Min reward as mid reward. From last time 4, now it become 5. Now max is also 5. Okay, then here if you calculate mid, so again 5 plus 5 to 10 divided 2, you get 5 only. But here you have already solved this case, right? Don't have to solve this actually, because my min is less than max. No, min is less than max. No, they are equal now. So that is not possible. So in the end, what you have to return, you have to return the min reward. Okay, so what was the min reward in the end? Min reward in the end was 5. So that's it, just return it. Okay, so if you see this example, so output is 5. Okay, that's it. Now let's write the code. Okay, same with just very few lines of code. Okay, so whatever I explained, I'm going to write the same thing. Okay, so first we have to store the maximum nums value in the max reward. Okay, so here int min reward. Okay, you can take 1, or you can take the minimum value from your nums array. Okay, it's your choice. Then int max reward. Okay, so you can just write one for each loop, and in for each loop just calculate the max of the max element in the nums. Okay, so that is one way. Or there is one more functionality that we can use. Okay, arrays dot stream. Okay, so using this we are streaming over all the nums. Okay, and in all the nums we are going to get the max. Okay, and I'm just going to get it as int type, get as int. Okay, so it will return me the max reward value. Okay, and then total houses. So you are going to take it as nums dot length. Okay, then after that we have to use the binary search to find the minimum reward possible. Okay, so here while min reward is less than max reward. Okay, so here after that int mid reward, okay, is equal to min reward plus mid reward divided by 2. Okay, and now here we have to just calculate the possible thefts. Okay, possible thefts. Okay, and just change it to 0. Okay, initially this variable is 0, then we have to run one for loop for int I is equal to 0, I is less than total houses, and I plus plus. All right, and inside this just you have to check if nums of index, okay, this I nums of I value, if it is less than equal to this mid range, that simply means that we can, using this value, we can form one pair. Okay, the one pair. Okay, so in that pair we can put the values, because we want the value such that our capability, it should be equal to mid range or less than mid range. Okay, that's the only way, only thing that we want. Okay, here, so in that case here we have to just increment the possible thefts, okay, by 1. Okay, plus equal to 1. All right, now here increment the index plus plus. Done. Okay, why we are doing this, we have to skip the next house to maintain the non-adjacent condition. Okay, that's the reason. All right, so this is done. This is here, this ends here, and then after that here inside this, so here we will just check if possible thefts. Okay, if it is greater than equal to k, then in that case we have to minimize the window of this capability. Okay, then we have to find the minimize that. Okay, so for that max reward is equal to mid reward value, whatever that we have to subtract 1 from it. Okay, and in the else, okay, if with that is it's not possible, then just increment the value. So so that we have to update min reward as mid reward plus 1. Okay, so that's simply means in the second half we have value, right? So this is done. So this is where my while loop ends, and here you have to simply return min reward. Okay, so we have to return min reward. All right, now let's run it and see if the encoding will try to fix that. Okay, yes, there are some issues, so let's try to fix that. So here this spelling mistake, change it to W. Let's run it again and see. So here there is one more issue. If nums of I here not mid range, it should be mid reward, right? So just correct these spellings. Okay, mid reward. All right, done. Now let's run it again. So here I, we are taking I. Okay, so let's run it again. All right, so here also min reward, mid reward, it should be max now, it should be max, min plus max divided by 2. Okay, so spelling mistake. All right, so now there is some issue. Let's see where we are getting, why we are getting this error. So let's see. Okay, so here this you can give mid reward only. Okay, max reward until this range you have to check. Okay, so now let's run it. Right, now let's submit it. All right, so see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.